Okay, hello students. So you all are welcome in my physics class. Today is the second class of discussion on the chapter 7, system of particles and rotation. You know that in our first class we have discussed about the motion of rigid body, how we consider, how we deal with the rigid body motion, and how we consider the rigid body as a system of particles. What are the concept behind that matter? We all discuss these things, and also we discuss the things about the rigid body. We have got the definition of rigid body and how it's characteristic. We all discuss these things. Let's we start today's topic by a question, and this question is also our topic, and this question is what kind of motion can a rigid body have? So students, in the previous class we have understood that whenever we going to discuss the motion of a extended body, we consider the extended body as a rigid body, and if we consider the rigid body, then we can easily we can easily discuss the motion of the extended body very in such way. So the question is very fantastic question. What kind of motion can a rigid body have? Now, okay, so to explore this question, let's we take some examples. Okay, here you can see a inclined plane. Inclined plane, that's inclined plane can be named as ABC. The C is not present here. You can put it yourself. So ABC is an inclined plane. Let's take, and on this inclined plane you can see a block. The block may be wooden block, but it must be rigid body. Okay, so here a rigid block or rigid body is present on the wooden block, and this block is moving down from A to B without any sidewise motion. That means the wooden block is sliding down, and it has no sidewise motion or orientation. Okay, so in that body we can consider this the rigid body, na? So we can consider this is the system of particles. So inside the body we can see two particles p1 and p2. We know that there are enormous huge number of particles present, but for this concept, for simplicity, we consider only the two particles p1 and p2. So you can see here, when the block is sliding down, the particles p1 and p2 also moving in the same manner. Okay, and they covered the same distances at the same time of interval. That means they are moving at the same time. They are moving in the same time. They are moving in the same directions. Okay, in the same directions. That means they are uniform motion, or we can say this system, this body is in uniform or pure translational motion. Pure translational motion, that means here it is a pure translational motion. Okay, the motion of this wooden block can be treated can be treated as pure translational motion. So now the question is arise, what is pure translational motion? Okay, let's we discuss about the pure translational motion. First of all, what is pure translational motion? Let's we define it. Okay, in pure translational motion you can see that the particles present inside the object, every particles present inside the rigid body have the same velocities, at any instant of time. Because why they have the same velocities? Because they always moving in the same directions, they always start moving at the same time, and these particles cover equal distances in equal time of interval. That means they have the same velocities. Okay, so in translational motion, in pure, or we can say the translational motion only, in pure translational motion, all particles all particles have same same velocities at any instant of time. Okay, so students, let's we repeat once again the characteristics of the pure translational motion. So pure translational motion have some characteristics. Okay, first characteristic is that the particles have the same velocities. That means they we can write all particles cover equal distance equal distances in equal time interval. Okay, secondly, they all have same velocities. Okay, and the path type, one important characteristics of the translational motion is path sorry one important characteristics of the translational motion is path type. Okay, what are the path type of the pure translational motion? In pure translational motion, the path type may be two. One is that uh, rectilinear rectilinear path rectilinear path, and secondly is the it curvilinear. Okay, second path type is curvilinear. That means, in other way, we can categorize the pure translational motion into two groups. One is the rectilinear rectilinear translational motion, and second is the curvilinear translational motion. Okay, these two type pure translation, these are the two types of pure translational motion. So we have got the important things about the translational motion here. We can easily understood that this wooden block is in pure translational motion. Why? Because here these all particles have the same velocities at any instant of time. Why they have same velocities? Because they all time cover the equal distances in equal interval of time, and they have the same directions. Their velocities have the same directions, they are moving in the same direction. Okay, that's why these all particles are in pure translational motion, and result is that this wooden block, maybe the wooden block or maybe the iron block, anything maybe happen, this block also have the pure translational motion. And one more things is that important is that there will be no orientation in pure translational motion. That means orientation change is not possible in pure translational motion. Okay, so another important point is that in pure translation motion there is no change of orientation. In pure translation motion, let's I write it in the above portion so that you can easily understood it, you can note it down. So let's here the number 3, the point number 3. Okay, let's I write it in left side so that you can got this point very easily. uh, in pure translational motion, no change of orientation. Orientation is possible. Okay, so when the object is in pure translational motion, the object cannot perform sidewise motion, and it cannot oriented, it cannot rotate. The object cannot be rotated in pure translational motion. So only it can move in a particular direction. That direction may be in a curvilinear direction, that direction may be curvilinear direction, or that line direction may be rectilinear direction. That means we have the examples of the translational motions. And let's see, give the example of translational motion. For the rectilinear motion, you all know that what are the examples of rectilinear motion. When a bus, when a car moving along a straight path, when a bike just move down along a straight path, these are the example of rectilinear pure translational motion. And whenever we throw a ball, whenever we throw a stone in air, and it follows, you know that balls or the stone will follow the projectile path, and that also be example of the curvilinear pure translational motion. If we have zero orientation, if there is no change of orientation of the object, that means the ball or the stone. That means a stone, if the stone is throwing in air and it has no orientation, or its orientation is not changed, then it is also considered as a curvilinear pure translational motion. I hope you have understood about the translational motion, and what are the pure translational motion and the kind of pure translational motions. You know that there are two types of pure translational motions. One is the rectilinear translational motion and curvilinear translational motion. And what are the characteristics of pure translational motions? What are the criteria? I hope you have understood. If you have any doubt, any question, or any suggestion, you can share with me. In this class, this is the end point, and in the next video we will discuss one another example, and in that example some different things we will discuss, and we will got some different point also. In that point we will stop. We cannot analysis the motion of that object, and a question will arise in that portion. If we consider only the translational motion, that question cannot be answered. So let's we meet for the next topic, for the next example, okay, in our third class. So till then, bye bye.